Chapter 4, Presentation, Analysis, and Interpretation of Data. So the purpose of this chapter is to summarize the collected data, how it was analyzed, and then to present the results. This section of chapter 4 briefly restates the statement of the problem or the SOP, the methodology, the research questions, hypotheses or phenomena, and then offers a statement about what will be covered in this chapter. So it should present the results of the study as clearly as possible. Before presenting the data, the first thing to do is to have a preparation of data for presentation. A good data preparation allows for efficient analysis, limits errors and inaccuracies that can occur to data during processing, and makes all processed data more accessible to users. So what is data presentation? It is the first phase of transforming raw data into useful information that will later be used for decision making. So you will use the tally charts. This is an example. After collecting the data, then you have to tally first. Then after the result, you have to transfer it to the presentation of data. Objectives. At the end of the topic, you will be able to understand the presentation of data, identify what is the best possible way of presenting data, effectively present the gathered data through graphs, tables, and figures. So let's start. Introduction to the chapter. So in chapter 4, in making your thesis, there must be an introduction first. So it covers below. The first is to introduce the purpose of the research study, then briefly describe the research methodology and or research questions or hypothesis tested, and provides an orienting statement about what will be covered in the chapter. So presentation. Presentation is the process of organizing data into logical, sequential, and meaningful categories and classification to make them amiable to study and interpretation. So there are three ways of presenting data. We have textual presentation, tabular presentation, and graphical presentation. So let's start with the textual presentation. So textual presentation, statements with numerals or numbers that serve as supplements to tabular presentation. Textual presentation of data means presenting the data in the form of words, sentences, and paragraphs. The text should be so written that it allows the reader to understand the argument presented without referring to the table. It helps the researcher explain and analyze these specific points of data. So here are the examples of textual presentation of data. So the first is symbolic. So in text, it should be letters, numbers, characters, making up the alphabet. Or lexical, words and all their variation about root forms, syntactic, grammatical rules, phrase and sentence structure, and semantic, meaning, perspective, understanding decisions regarding beliefs or actions. The next ways of presenting the data is tabular presentation. It is a systematic arrangement of related idea in which classes of numeral facts or data are given each row and their subclasses are given each a column in order to present the relationships of the sets or numerical facts or data in a definite, compact, and understandable form. So table presentation are concise, and because data are systematically grouped and arranged, explanatory matter is minimal. So tables also given whole information even without combining numerals with textual matter. It can be easily constructed and understood even without reading the text. So here is the example of the table presentation. This is the total population distribution by region year 2000. So the region, population, and percent. Tables includes title, number, heading, body, notes, and source. So let's have the first, which is the title. The title should identify the table briefly. So the title of the table is the second item that is shown just above the table. It narrates the contents of the table, hence it has to be very clear, brief, and carefully worded. So in the title, we have the table title format. So we have inverted pyramid. As you can see in the slide, naka-center siya. Paragraph form, so yun yung example. Then block style, naka-align siya sa left. So in this example, it is a inverted pyramid. So as you can see this, naka-center siya. So next is number. Number all tables with Arabic numerals sequentially. So the table number is the very first item mentioned on the top of each table for easy identification and further reference. So we have here table 1, followed by table 2, table 3, and so on and so forth. So next is heading. So generally expressed in phrase or clause, so it contains the stub and box head. So stub is the vertical column to the far left of a table in which you list the various line headings that identify the horizontal rows of data in the body of the table. So ito yung stub. Ito yung stub. Then the box head. The horizontal region across the top of the table containing column headings with units of measurement clearly identified. So ito yung box head. So itong part na to. So stub ay nahahati sa dalawa. So we have stub heads and row labels. So stub heads describe the row heads before it. So ito yung stub heads. Then row labels allow you to choose the most important column in the table. So, ito yun. Then, sa box head, nahati naman sa tatlo. So, we have the master caption, describe the column caption. So, ito yun. Ito ang pinakang taas. Then, column caption, describe the sub-column. So, ito yun. Itong part na to. Then, column subcaption, describing the contents of a row of data. So, ito yon. The next is body. So, the body or text of the table contains all the quantitative and proportional information presented in the table in rows and in columns. So, as you can see, so ito yung body. So, nilalaman ng body is yung mga information or mga na-collect na data. Then, notes. It explains the specific feature of the table which is not self-explanatory and has not been explained earlier. So, if there are items in the table that are not easily understood, so you can go to the note or see the note. So a note ay nasa babang parte ng table. Then the source. It is a brief statement or phrase indicating the source of data presented in the table. So, naka-circle siya. Circle. So, source, ito yung reference. So, table data spacing. So, the first, it plays after text. Observe 4 spaces from the text to table number. For example, after the paragraph or text, so magkakaroon ng 4 spaces bago yung table number. So, yung table number, Arabic number consecutively throughout the paper. Table 1, table 2, and so on and so forth. So, after table number, so magkakaroon ng double space, then the title. The title should be upper and lowercase. Then, double space bago dun sa table. Malagay dito, capitalize only the first word of column headings. Unless proper noun or adjective, observe parallelism in constructing the headings. Then leave a space before and after headings. So, dito sa raw data, no period for words or phrases. For example, Masters in Business Administration, so walang siyang tuldok. Then, align all items listed in a table within and between entries. If text follows table, observe for space before typing the first line of the text. Never break your tables. Fit them in a page. You may adjust the font size to fit in. So, ito yung table spacing. So, next is graphical presentation. Graphical presentation is a chart representing the quantitative variations or changes of variables in pictorial or diagrammatic form. So we have types of graphs and charts. So we have bar graphs, linear graphs, pie graphs, pictograms, statistical maps, and ratio charts. First is bar graphs. A graph which consists of parallel bars or rectangles with lengths that are equal to quantities that occur in a given data set. So these bars can be presented vertically or horizontally to show the contrast and record information. So sometimes called a column bar chart. So as you can see in the picture, those are examples of bar graphs. So, pwede siyang naka-vertical, pwede din naka-horizontal. Next is linear graphs or line graph. A graph that displays information in a series of data points that each represents an individual measurement or piece of data. The series of points are then connected by a line to show a visual trend in data over a period of time. So as you can see, the picture, those are examples of a linear graphs or line graph. So may mga points siya. So next is pie graphs or circle graph. A circle divided into sections which each display the size of a relative piece of information. In a pie graph, the length of each sector is proportional to the percentage it represents. So here are the examples of a pie graph or circle graph. So next is pictographs. It is a way of representing statistical data using symbolic figures or pictorial resemblance to match the frequencies of different kinds of data. It is often used in writing and graphic systems in which the characters are to a considerable extent pictorial in appearance. So as you can see in the pictures, those are examples of pictographs. So let's have statistical maps or map graph or cartogram. A presentation of statistical data in geographical distribution on a map. A map that may contain either of the following: so land area, distance, population, and travel time. So as you can see in the picture, those are examples of statistical maps or map graph or cartogram. So let's have the ratio charts. A chart employing the Cartesian coordinate system in which the points on a curve are determined by measuring time as the independent variable along one axis and the logarithms of the values of the corresponding dependent variables along the other. So as you can see in the picture, those are examples of ratio charts. A curve yung presentation ng data.
Good day, this is Jay. Together with Mom Abby, we're going to discuss about the analysis part of the BII. First, let's discuss what is analysis. According to Merriam-Webster Dictionary, analysis is the separation of a whole into its constituent parts. Analysis in research, it is the process of breaking up the whole study into its constituent parts of categories according to specific questions under the statement of the problem. There are two ways of data analysis: the qualitative analysis and the quantitative analysis. The definition of research in data analysis. What is data analysis and research? The research data analysis is a process used by researchers for reducing data to a story and interpreting it to derive insights. The data analysis process helps in reducing a large chunk of data into smaller fragments, which makes sense. Why analyze data in research? Researchers rely heavily on data as they have the story to tell or problems to solve. It starts with a question, and data is nothing but an answer to that question. But what if there's no question to ask? Well, it is possible to explore data even without a problem, and we call it data mining, which often reveals some interesting patterns within the data that are worth exploring. Irrelevant to the type of data, researchers explore their mission and audience's vision guide them to find the patterns to shape the story they want to tell. One of the essential things expected from researchers while analyzing data is to stay open and remain unbiased towards unexpected patterns, expressions, and results. Remember, sometimes data analysis tells the most unforeseen yet exciting stories that were not expected at the time of initiating data analysis. Therefore, rely on the data you have at hand and enjoy the journey of exploratory research. What is qualitative analysis? Qualitative analysis is concerned with the analysis of data that cannot be quantified. This type of data is about the understanding and insights into the properties and attributes of objects, such as participants. Qualitative analysis can get a deeper understanding of why a certain phenomenon occurs. The analysis can be used in conjunction with quantitative analysis or precede it. Unlike in quantitative analysis that is restricted by certain classification rules or numbers, qualitative data analysis can be wide-range and multifaceted. It is subjective, descriptive, non-statistical, and exploratory in nature. Because qualitative analysis seeks to get deeper understanding, the researcher must be well-rounded with whichever physical properties or attributes the study is based on. Oftentimes, the researcher may have a relationship with the participants where their characteristics are disclosed. In a quantitative analysis, the characteristics of objects are often undisclosed. The typical data analyzed qualitatively include color, gender, nationality, taste, appearance, and many more, as long as the data cannot be computed. Such data is obtained using interviews or observations. Examples of qualitative analysis. Qualitative analysis focuses on why. Why do people behave in certain ways? Why do they make decisions? Qualitative analysis and research methods often include these examples. 1. Focus groups. 2. Questionnaires and surveys. 3. Interviews. 4. Unstructured observations. For example, like reading social media posts. 5. Expert opinions. Qualitative analysis tend to look very deeply at a few things to understand the why. Now let's discuss about these examples. First example, focus groups. Focus groups are a form group interview that capitalizes on communication between research participants in order to generate data. Although group interviews are often used simply as a quick and convenient way to collect data from several people simultaneously, focus groups explicitly use group interaction as part of the method. This means that instead of the researcher asking each person to respond to a question in turn, people are encouraged to talk to one another, asking questions, exchanging anecdotes, and commenting on each other's experiences and points of view. The method is particularly useful for exploring people's knowledge and experiences and can be used to examine not only what people think, but how they think and why they think that way. Next is questionnaires and surveys. Qualitative surveys use open-ended questions to produce long-form written or typed answers. Questions will aim to reveal opinions, experiences, narratives, or accounts, often a useful precursor to interviews or focus groups as they help identify initial themes or issues, then explore further in the research. Surveys can be used iteratively, being changed and modified over the course of the research to elicit new information. Here are some examples of surveys. First is the face-to-face survey. Researcher asks participants one or more open-ended questions about a topic, typically while in view of participants' facial expressions and other behaviors while answering. Being able to view the respondents' reactions enables the researchers to ask a follow-up questions to elicit a more detailed response and to follow up on any facial or behavioral cues that seem at odds with what the participant is explicitly saying. Second, telephone surveys. In telephone surveys, similar to the face-to-face method, but without researcher being able to see the participants' facial or behavioral responses to the questions asked. This means the researcher may miss the cues that would help them ask further questions to clarify or extend participant responses to their questions, and instead relies on vocal cues. And lastly, the online surveys. In online surveys, it is their open-ended questions are presented to participants in written format via email or within an email survey tool. Online surveys can collect a greater number of responses in a great or set period of time compared to the face-to-face and phone survey approaches. Next is interviews. Interviews collect in-depth content in a one-on-one setting that can be used to better understand a topic or issue. Let's say you're planning on conducting a survey measuring worker satisfaction in your company. Before creating your survey, it could be beneficial to conduct interviews to gain some context of the company culture, working conditions, and other concerns that are specific to your company or area. Interviews also give you the opportunity to ask follow-up questions, to read body language, and pick up on another subtle cues that a more quantitative research method might not. In addition to learning more about the topic, interviews can also be used to create case studies and gather expert opinions. Observational research. This approach involves observing customers or people in their actual element. A perfect example would be watching shoppers while they visit your store. How long does it take them to find what they're looking for? Do they look comfortable? interacting with your staff? Where did they go first? Then second, when did they leave without making a purchase? These real-world observations can lead you to findings that more direct forms of research, like focus groups and interviews, would miss. Lastly, expert opinions. Many people use expert opinions to gain informed insights on a particular topic. For example, you may be interested in learning about a topic that you don't know much, like survey best practices. In this case, you're probably best conducting a few interviews with experts on the subject. In this way, you can ask several open-ended questions and receive the high-quality information needed to better understand the topic. For additional notes, qualitative analysis fundamentally means to measure something by its quality rather than quantity. When we do qualitative analysis, we are exploring how we describe something. Very often, we cannot use numbers or numerical expressions to describe those things. When we do qualitative work, we work with descriptions. We work with feelings, thoughts, perceptions. We attempt to understand motivations and behaviors. Now, let's talk about the quantitative analysis to be discussed by Ma'am Abby.
So, good afternoon, everyone. I hope you are all fine and doing well. So, we are still in the analysis part of Chapter 4. We are done with the qualitative part as discussed a while ago by Francis. So, now let's proceed with the quantitative analysis. So, quantitative analysis is often associated with numerical analysis where data is collected, classified, and then computed for certain findings using a set of statistical methods. So, data is chosen randomly in large samples and then analyzed. The advantage of quantitative analysis is that the findings can be applied in a general population using research patterns developed in the sample. So this is a shortcoming of qualitative data analysis because of limited generalization of findings. Quantitative analysis is more objective in nature, and it seeks to understand the occurrence of events and then describe them using statistical methods. However, more clarity can be obtained by concurrently using qualitative and quantitative methods. Quantitative analysis normally leaves the random and scarce events in research results, whereas qualitative analysis considers them. So, quantitative analysis is generally concerned with measurable quantities such as weight, length, temperature, speed, width, and many more. And quantitative data can be classified as continuous or discrete, and it is often obtained using surveys, observations, experiments, or interviews. So the data can be expressed in a tabular form or any diagrammatic representation using graphs or charts. So there are, however, limitations in quantitative analysis. For instance, it can be challenging to uncover relatively new concepts using quantitative analysis, and that is where qualitative analysis come into the equation to find out why a certain phenomenon occurs. That is why the method are often used simultaneously. So, quantitative analysis is the opposite of qualitative. So, to measure by quantity rather than quality. When we do quantitative analysis, we are exploring facts, measures, numbers, and percentages. When we do quantitative work, we work with numbers, statistics, formula, and data. So here are the examples of quantitative analysis. We have close-ended questionnaires and surveys. And next, we have the structured data, large-scale data sets, and lastly, we have random sampling. So close-ended questionnaires or surveys. So close-ended questions are defined as question types that ask respondents to choose from a distinct set of predefined responses, such as yes or no, or among set of multiple choice questions. So in a typical scenario, close-ended questions are used to gather quantitative data from respondents. And close-ended questions come in a multitude of forms but are defined by their need to have explicit options for a respondent to select from. However, one should opt for the most applicable question type on a case-by-case basis, depending on the objective of the survey. So to understand more about the close-ended question, let us know first its types. So first is dichotomous question. These close-ended questions are indicative questions that can be answered either in one of the two ways, either yes or no, or true or false. So here in our example, we have question here. So what do you think of Starbucks? Either you select you love it or you hate it. So next we have multiple choice question. A multiple choice close-ended questions are easy and flexible and helps the researcher obtain data that is clean and easy to analyze. It typically consists of STEM, the question, correct answer, closest alternative, and distractors. Next, we have rating scale multiple questions. These close-ended questions require the respondent to assign a fixed value in response, usually numeric. So the number of scale points depends on what sort of questions a researcher is asking. So next we have a checklist type multiple choice questions. So this type of close-ended questions expect the respondents to make decisions from the many options that have been stated. So the respondent can choose one or more options depending on the question being asked. Next, we have rank order multiple choice questions. So these close-ended questions come with multiple options from which the respondent can choose based on their preference, from the most preferred to least preferred, so usually in bullet points. So next, random sampling. Simple random sampling is defined as a sampling technique where every item in the population has an even chance and likelihood of being selected in the sample. So here, the selection of items entirely depends on luck or probability, and therefore, this sampling technique is also sometimes known as method of chances. So since simple random sampling is a fundamental sampling method and can easily be a component of a more complex sampling method, the main attribute of this sampling method is that every sample has the same probability of being chosen. So here are the steps to conduct simple random sampling. So number one, make a list. So let's make an example. So example, you will make a list of all the employees working in the organization. So example, there are 500 employees in the organization. So the record must contain 500 names. So number two, assign a sequential number. So you will assign a sequential number to each employee. 1, 2, 3, 4, 5, and so on and so forth. So this is your sampling frame. So the days from which you draw your simple random sample. So next, choose sample size. So figure out what your sample size is going to be. So in this case example, the sample size is 100. And next, use random number generator. So you will use a random number generator to select the sample using your sampling frame or the population size from step 2 and your sample size from step 3. So for example, if your sample size is 100 and your population is 500, so you will generate 100 random numbers between 1 and 500. So next we have structured data. Structured data, typically categorized as quantitative data that is highly organized and easily decipherable by machine learning algorithms. So, developed by IBM in 1974, structured query language or SQL is the programming language used to manage structured data. So, by using a relational SQL database, business users can quickly input, search, and manipulate structured data. So this is an example of a large-scale data sets. So large-scale data analysis is the process of applying data analysis techniques to a large amount of data, typically in big data repositories. It uses specialized algorithms, systems, and processes to review, analyze, and present information in a form that is more meaningful for organizations or end users. So in this picture, this is an example of a colon cancer microarray dataset that is used in this research. So let's proceed with the visualization techniques in data analysis. So one of the best practices of data interpretation is the visualization of the dataset. Visualization makes it easy for a layman to understand the data and encourages people to view the data as it provides a visually appealing summary of the data. So there are different techniques of data visualization. So let's discuss it one by one. So first is the bar graphs. Bar graphs are graphs that interpret the relationship between two or more variables using rectangular bars. So these rectangular bars can be drawn either vertically or horizontally, but they are mostly drawn vertically. The graph contains the horizontal axis, which is the x, and the vertical axis, the y, with the former representing the independent variable, while the latter is the dependent variable. So bar graphs can be grouped into different types depending on how the rectangular bars are placed on the graph. So here are the some types of bar graphs. So first is the group bar graph. So the group bar graph is used to show more information about variables that are subgroups of the same group, with each subgroup bar placed side by side like in a histogram. Next is the stack bar graph. A stack bar graph is a group bar graph with its rectangular bars stacked on top of each other rather than placed side by side. So next is the segmented bar graph. Segmented bar graphs are stacked bar graphs where each rectangular bar shows 100% of the dependent variable. It is mostly used when there is an intersection between the variable categories. So the following is a step-by-step example, and it shows how to create a segmented bar chart for a dataset. So step 1, collect the data. So suppose we go out and ask 100 students at a certain college to tell us their favorite sport. So the following table shows the results of the survey. So based on the gender and favorite sport. Step 2, we will convert the data to percentages. So next, let's convert the raw frequencies into percentages. For example, here's how to convert the frequencies into percentages for baseball category. So number 1, there are number of respondents who were males. So 13 over 36 is equals to 36.1%. For the numbers of respondents who were female, we have 23 over 36, which is equivalent to 63.9%. And we can repeat the same process for the basketball. So the number of respondents who were male, we have 15 over 31, which is equivalent to 48.4%. And the number of respondents who were female are 16.31, and which is equivalent to 51.6%. So same process with the football. So the number of respondents who were male, we have 20 over 33 for an equivalent of 60.6%. And number of respondents who were female, we have 13 over 33. We have 39.4%. So this leaves us with the following table. So ayan. So ito na yung kinalabasan niya. So next, step 3 is to create the segmented bar chart. So we can create the segmented bar chart by using 3 separate bars. So one for each sport and filing in the bars according to the percentage of respondents who were male or female. So this helps us quickly understand the breakdown of the percentages of students who prefer each sport based on gender. For example, we can see that out of the respondents who choose football as their favorite sport, about 60% of them were male. Conversely, out of the respondents who chose baseball as their favorite sport, so less than 40% of them were male. So next, let's discuss the advantages of a bar graph. So first, it helps us to summarize a large data. Next, estimation of key values can be made at a glance and it can be easily understood. So the disadvantages naman of a bar graph are, number one, it may require additional explanation. It can be easily manipulated and it doesn't properly describe the dataset. Next, we have a pie chart. A pie chart is a circular graph used to represent the percentage of occurrence of a variable using sectors. The size of each sector is dependent on the frequency or percentage of the corresponding variables. So there are different variants of the pie charts, but we will be restricting ourselves to only 3. So for better illustration of these types, let us consider the following examples. Example, there are a total of 50 students in a class, and out of them, 10 students like football, and 25 students like snooker, and 15 students like badminton. So the simple pie chart is the most basic type of pie chart, which is used to depict the general representation of a bar graph. While the donut pie is a variant of the pie chart with a blank center allowing for additional information about the data as a whole to be included. Next, we have the 3D pie chart. 3D pie chart is used to give the chart a 3D look and is often used for aesthetic purposes. It is usually difficult to reach because of the distortion of the perspective due to the third dimension. So advantages of pie chart, number one, it is usually appealing. And next, it is best for comparing small data samples. So disadvantages of pie chart, it can only compare small sample sizes and it is unhelpful with observing trends over time. Next, we have the tables. Tables are used to represent statistical data by placing them in rows and columns. They are one of the most common statistical visualization techniques and are of two main types, namely simple and complex tables. Simple tables summarize information in a single characteristic and may also be called a univariate table. An example of a simple table showing the number of employed people in a community concerning their age group. Now let's discuss what are the advantages and disadvantages of tables. Advantages of tables, number one, it can contain large data sets and it is helpful in comparing two or more similar things. While the disadvantages of this are, number one, they do not give detailed information and it may be time consuming. Next, we have line graph. Line graphs or charts are a type of graph that displays information as a series of points usually connected by a straight line. So here are some types of line graphs. So first is the simple line graphs. Simple line graph shows the trend of data over time and may also be used to compare categories. Let us assume we got the sales data of a firm for each quarter and are to visualize it using a line graph to estimate sales for the next year. So line graphs with markers. These are similar to line graphs but have visible markers illustrating the data points. So stack line graphs are line graphs where the points do not overlap and the graphs are therefore placed on top of each other. Consider that we got the quarterly sales data for each product sold by the company and are to visualize it to predict company sales for the next year. So here are the advantages and disadvantages of line graph. So first advantage is that it is great for visualizing trends and changes over time. And next, it is simple to construct and read. While the disadvantages of this is that it cannot compare different variables at a single place or time. So to give us a summary, here's a comparison chart between a qualitative analysis versus the quantitative analysis. So qualitative analysis is subjective analysis that is more concerned with non-statistical data that cannot be computed. While in quantitative analysis, it is an objective analysis that quantifies data. Next, in qualitative analysis, the typical data include color, gender, nationality, religion, and many more. While in quantitative analysis, typical data include measurable quantities such as length, size, weight, mass, and many more. Next, in qualitative analysis, the analysis is used to understand why a certain phenomenon occurs, while in quantitative analysis, the analysis is concerned with how many or how much a certain phenomenon occurs. Next, in qualitative analysis, the sample is small and is non-representative of the entire population, while in quantitative analysis, the sample is large and can be generalized to cover the entire population. And next, qualitative analysis interprets and understands social interaction, while in quantitative analysis, it tests hypotheses and gives future prediction. And lastly, qualitative analysis. In qualitative analysis, research methodology is exploratory, while in quantitative analysis, research methodology is often conclusive. Alright, so that's it. So thank you everyone for listening, and I hope you learned a lot from our discussion for today. So next we will proceed with the interpretation of data, which will be discussed by Ms. Karol Valenton. Thank you.
Hi, good afternoon, everyone. My name is Carol, and today I'll be discussing data interpretation. And before I start, can we all give the previous presenters a big round of applause for doing a great job? Thank you. And I also hope that you find value and you would learn something from my report. So let's start. So what is data interpretation? Data interpretation is the process of reviewing data through some predefined processes, which will help assign some meaning to the data and arrive at a relevant conclusion. So this section answers the question, so what, in relation to the results of the study, and what do the results of the study mean? It involves taking the result of data analysis, making inferences on the relations studied, and using them to conclude. This part is perhaps the most critical aspect of your research report. It is evident that the interpretation of data is very important and as such needs to be done properly. It is often the most difficult to write because it is the least structured. Therefore, we have identified some methodologies to aid us in this process. So what are data interpretation methods? Data interpretation methods are how analysts help people make sense of numerical data that has been collected, analyzed, and presented. Data, when collected in raw form, may be difficult for us to understand, which is why analysts or the researchers need to break them down so that others can make sense of it. So, for example, is pitching to potential investors. You must interpret the data for a better understanding. So, an example of these data are market size and growth rate. And there are two main methods in which this can be done. So, namely quantitative methods and qualitative methods. Okay, so our first method is the qualitative data interpretation method. This method is used to analyze qualitative data, which is also known as categorical data. This method uses text rather than numbers or patterns to describe data. So what is qualitative data? You may have heard this during our statistics class. Qualitative data is usually gathered using a wide variety of person-to-person techniques, which may be difficult to analyze compared to the quantitative research method. So unlike the quantitative data, which can be analyzed directly after it has been collected and sorted, qualitative data needs to first be coded into numbers before it can be analyzed. This is because texts are usually cumbersome or they're heavy and difficult and will take more time and result in a lot of errors if analyzed in their original state. Coding should also be documented so that it can be reused by others and also analyzed. There are two main types of qualitative data. So first is the nominal data and second would be the ordinal data. So nominal data is defined as data that is used for naming or labeling variables without any quantitative value. It is sometimes called named data, a meaning coined from the word nominal. There is usually no intrinsic ordering to nominal data. For example, race is a nominal variable having a number of categories, but there is no specific way to order from highest to lowest and vice versa. So next would be the ordinal data. Ordinal data is a type of categorical data with an order. The variables in ordinal data are listed in an ordered manner. The ordinal variables are usually numbered so as to indicate the order of the list. However, the numbers are not mathematically measured or determined, but are merely assigned as labels for opinions. Our second methodology would be the quantitative data interpretation method. So this method is used to analyze quantitative data, which is also known as numerical data. This data type contains numbers and is therefore analyzed with the use of numbers and not texts. Quantitative data are of two main types, namely discrete and continuous data. Continuous data is further divided into interval data and ratio data, with all the data types being numeric. Okay, so now we discuss the tips for collecting accurate data for interpretation. Okay, so the first tip would be to identify the required data type. So as researchers, we need to identify the type of data required for our particular research. If the data is going to be nominal, ordinal, interval, or ratio. So the key to collecting the required data to conduct your research is to properly understand the research question. So if you as a researcher can understand the research question, then you can identify the kind of data that is required to carry out your research. For example, when collecting customer feedback, the best data type to use is the ordinal data type. Ordinal data can be used to access a customer's feelings about a brand and is also easy to interpret. The second tip would be to avoid biases. There are different kinds of biases a researcher might encounter when collecting data for analysis. Although biases sometimes come from the researcher, most of the biases encountered during the data collection process is caused by the respondent. So there are two main biases, namely the response bias and the non-response bias. So researchers may not be able to eliminate these biases, but there are ways in which they can be avoided and reduced to a minimum. So response biases are biases that are caused by respondents intentionally giving wrong answers to responses, while non-response bias occurs when the respondents don't give answers to questions at all. So biases are capable of affecting the process of data interpretation. Okay, the third tip would be to use close-ended surveys. Although open-ended surveys are capable of giving detailed information about the questions and allowing respondents to fully express themselves, it is not the best kind of survey for data interpretation. It requires a lot of coding before the data can be analyzed. Close-ended surveys, on the other hand, restrict the respondents' answers to some predefined options, while simultaneously eliminating irrelevant data. This way, researchers can easily analyze and interpret data. However, close-ended surveys may not be applicable in some cases, like when collecting specific information, like respondents' personal information, specifically like name, credit card details, and phone numbers. Okay, all right. So what are the steps in interpreting data? After data collection, you'd want to know the result of your findings. And ultimately, the findings of your data will be largely dependent on the questions you've asked in your survey or your initial study questions. So in the next slides, we'll be discussing the 4 steps for accurately interpreting data. Okay, so the first step would be to gather the data. The very first step in interpreting data is having all the relevant data assembled. You can do this by visualizing it first either in a bar, graph, or a pie chart. The purpose of this step is to accurately analyze the data without any bias. Now is the time to remember the details of how you conducted the research. Were there any flaws or changes that occurred when gathering this data? Did you keep any observatory notes and indicators? Once you have your complete data, you can move to the next stage. The second step would be to develop your findings. This is the summary of your observations. Here you observe this data thoroughly to find trends, patterns, or behavior. If you are researching about a group of people through a sample population, this is where you analyze behavioral patterns. The purpose of this step is to compare these deductions before drawing any conclusions. You can compare these deductions with each other, similar data sets in the past, or general deductions in your industry. So the third step is to derive conclusions. Once you've developed your findings from your data sets, you can then draw conclusions based on trends you've discovered. Your conclusions should answer the questions that led you to your research. If they do not answer these questions, ask why. It may lead to further research or subsequent questions. The fourth and last step would be to give recommendations. For every research conclusion, there has to be a recommendation. This is the final step in data interpretation because recommendations are a summary of your findings and conclusions. For recommendations, it can only go in one of two ways. You can either recommend a line of action or recommend that further research be conducted. So what are the advantages and importance of data interpretation? First is that data interpretation is important because it helps make data-driven decisions. So entrepreneurs or business owners or leaders can make decisions that are based on facts, based on behaviors and the results of studies. Second would be it saves costs by providing costing opportunities. So a perfect example would be in the contact center or BPO industry. I have experienced doing costing before for headcount and also relating it to employee utilization. Of course, it is based on studies and data interpretation. Lastly would be the insights and findings from interpretation can be used to spot trends in a sector or industry. Okay, and to summarize, data interpretation and analysis is an important aspect of working with data sets in any field or research and statistics. They both go hand in hand as the process of data interpretation involves the analysis of data. And the process of data interpretation is usually cumbersome and should naturally become more difficult with the best amount of data that is being churned out daily. However, with the accessibility of data analysis tools and machine learning techniques, analysts are gradually finding it easier to interpret data. Uh, Data interpretation is very important as it helps to acquire useful information from a pool of irrelevant ones while making informed decisions. It is found useful for individuals, businesses, and researchers. So that concludes my presentation. I would like to thank everyone for listening. Thank you very much for your time, and I do hope that you were able to learn something, that you were able to get valuable insights from this presentation, and I hope that it would help you in your research. Thank you very much, and I wish you a very wonderful weekend. Thank you.
Hello everyone. Good afternoon classmates. Good afternoon Doc. After we hear the reports regarding the principles and concepts of Chapter 4, the presentation, analysis, and interpretation of data, we are going to discuss how are we going to write our Chapter 4. We have here some guides or steps that we can use in writing in this part of our study and provide some samples on how to implement these guides or steps. Okay, let's start with the first one. Step number 1. Remind your reader of the purpose of your study. This chapter 4 should provide the product of your analytic process. Sometimes it can be called a stand-alone chapter that you could hand to a friend, or by just reading it, they would know exactly what you discovered through your study. This chapter should reveal the answer to your research question and reflect the design you put forward in chapter 2. which is the review of related literature. It should also align with the purpose of the study you offered in Chapter 1, which is the statement of the problem, as well as demonstrate why the study was important to conduct in the first place. We have here an example of how the researcher presents the purpose of his or her study. Having clarified the concept of incorporation, the purpose of this chapter is to analyze and interpret the elicited perceptions and experiences of postnatal patients, family members, traditional birth attendants, registered midwives, midwifery lecturers, and the maternal and child healthcare coordinators to use in the development of a model for incorporating indigenous postnatal care practices into a midwifery healthcare system. So these are just the example of how he or she present the purpose of our study. The second is present the result of the statistical analysis in the tabular form, in table form. As discussed earlier, data are usually presented in charts, tables, or figures. Tables provide exact values and illustrate results efficiently as they enable the researcher to present a large amount of data in a small amount of space, while data analysis is the process of inspecting, rearranging, modifying, and transforming data to extract useful information from it. But in most cases, we may encounter many tables here, but the question is, how are we going to arrange these tables? Sino yung mauna, sino yung susunod, sino yung mahuli? We can use tables, charts, or figures in both qualitative and quantitative capstones. But take note, never present a table or charts or figure that you are not planning or explaining. We have to take note also that improper analysis always distorts the scientific findings and leads the reader to believe in a wrong notion. Inappropriate analysis not only limits numerical data but also affects non-statistical data too if the analyst or researchers has an integrity issue. Step number 3 is immediately below the table, present a narrative interpretation of the data. Analysis and interpretation will be the basis of the findings of the study. Narrative meaning using words to describe the value, to verbalize or make a story what is the meaning of those numeric values that we see in the table, like what is the meaning of the highest value or the lowest value, what is the meaning or narrative interpretation of the following value, and the third value, etc. In some cases, there are tables wherein meron silang numeric value and narrative description of the value. It is our responsibility to our reader that we think what is the most important information in the table, chart, or figure. Take note that we have here 4 levels of interpreting the data. Level 1, data collected are compared and contrasted. Level 2, explain the internal validity, consistency, reliability of results. Level 3 explains the external validity of the results, the applicability to external conditions. Level 4 relates or connects the interpretation of data with theory or with a view of related literature. Step number 4. If there are multiple results presented in the table, get the highest and the lowest value as a basis of narrative interpretation. What if there are so many values? Maraming numeric data. Example, there are 10 of them. We do not need to interpret and use all of these values. We have variation na pwedeng gamitin. Get the highest value, then interpret what is the meaning of that value. The lowest value, interpret what does it mean. And then the variation is you can get the highest, second to the highest, and the lowest. Another variation is the highest, the lowest, and the midpoint, the median of the value. So these are the variation that we can use in interpreting the result or that presented in one table. The highest numerical value, the lowest numerical value, the most common numerical value, the final numerical value. Again, we do not need to interpret all. Step number 5, provide a brief narrative to guide the discussion. meaning we do not just put the table, we also put the interpretation, another table, another interpretation in the middle of the tables. An interpretation must provide a brief narrative that will guide the transition of our discussion. We are not just presenting, we are also guiding the readers here. Ito po yung una, ang ibig sabihin at laman ng value niya ay ganito, at yung susunod based on our statement of the problem ay ganon. We have here an example of a table that provides a brief narrative guide about the discussion. The results indicate the improvement of the respondent ownership scores on the post-test. This indicates that most of the respondents have a tendency to blame sometimes others and deflect accountability for dealing with challenges. Step number 6, report descriptive analysis of demographics. This report depends on whether the study is quantitative or qualitative. Quantitative report uses frequencies and percentages, while qualitative reports uses text and detailed descriptions. In a qualitative study, the information to be reported is called findings. Findings are those themes that have emerged from or have been found in the data you have collected. They are the product of your analysis. Sample size, age range of participants, the genders, characteristics of the samples, details about organization, institutional class being studied, details about participants as is relevant to the topic being studied. In a quantitative analysis, study results of the quantitative analysis conducted may be presented on their own without any combined connection to a larger literature. When quantitative data are presented without any accompanying explanation, a discussion section is presented separately in order to explain the meaning of the results. Quantitative results are sample size, frequency, and percentages of demographic variables, the males or females, the age groups, the other variables, years of experience groups, answer to yes or no questions, reported educational, grades, types of schools. Step 7. Quantitative factor analysis. Tell how the factors were extracted. Outline the criteria and justification used to determine what factors are retained. Report the given names of the new scales developed. Step 8. Presenting quantitative results organized by research questions, hypotheses, use, statistical language annotation. We have to mention the name of the statistics, t-test, ANOVA, correlation, chi-square, etc., and what it was used for. Include appropriate statistical values, coefficient, p-values, standard deviations, mean, etc., the tables, the figures, the graphs, and charts. When crafting your findings, the first thing you want to think about is how you will organize your findings. Your findings represent the story you are going to tell in response to the research question you have answered. Thus, you will organize that story in a way that makes sense to you and will make sense to your reader. You will need to differentiate between presenting raw data and using data as evidence or examples to support the findings you have identified. In presenting the findings, here are some points to consider. Your findings should provide sufficient evidence from your data to support the conclusions you have made. Ethically, you have to make sure you have confidence in your findings and account for counter-evidence and not report something that does not have sufficient evidence to back it up. Your findings should be related to back your conceptual framework. You should focus on the data that enable you to answer your research question, not simply in offering raw data. Step 10. Presenting qualitative findings. Describe in detail the major themes found. In describing each theme, the participants' voices should be heard. Quotation must be included to support the analysis and interpretations. Assign pseudonyms or code the participant for ease of reference. When presenting qualitative data, all names must to provide confidentiality. We will make this commitment to our participants during the consent process. For example, we will use student 1 or teacher A or principal 2. Step 11. Summarize. The summary may differ between research tradition. In quantitative, summarize based on sample size, statistical procedures used, major results from each research question or hypothesis, any other analysis of interest performed. In qualitative, restate briefly the major themes which were uncovered, summarize using table, research question with major and sub-themes, participants with themes, data source with themes. In Chapter 4, we have to ensure that your result of findings match your research question in Chapter 1. The analysis you conducted match what you had stated in Chapter 3. You may include some citation to reinforce a point. 1 or 2 citation is enough. And do not present and make conclusion or recommendation in this part of the chapter, because as the content of Chapter 4 is only 3 areas: presentation, analysis, and interpretation. Other than that, do not include anything else that is not reflected in the title of this chapter, because our conclusion, our recommendation should be presented and written on the next chapter, which is Chapter 5, Summary Findings, Conclusions, and Recommendation. That is why we should only focus on this part of our research. Lastly, here are the components or chapter outline. In quantitative outline, first is the demographic analysis, the factor analysis, Hypothesis 1 or research question 1, Hypothesis 2 or research question number 2, Hypothesis 3 or research question number 3, other analysis, and then the summary. In qualitative outline, first is a demographic analysis, followed by percentage of findings. Third is the theme 1, research question 1 or data source 1, theme 2, theme 3, and then the summary. Thank you, and for